Lockheed Martin, Denver. We now have with us Phuc Lee. Phuc is a member of JPL's Executive Council, and he's the manager of NASA's Mars program. Welcome, Phuc.
Thank you.
First of all, we hear this staggering statistic that there are so many failures. It's a 50-50 chance of trying to land on Mars. Why is Mars so difficult?
I consider entry, descent, landing to be one of the most challenging, if not the most challenging thing that robotic missions have to do. The reason it's so challenging is that when we go through these 7 minutes of terror, the spacecraft has to go through a large number of actions on its own, the first time, and every single one has to be done correctly before we can succeed. And that's why, as you said, if you look at the international set of missions, over 50% of that have failed. So it is really a very challenging job for us.
Well, a sibling of this spacecraft, the Mars Polar Lander, did fail. And how are things being done differently this time?
Yes. When the project first looked into potentially flying this mission, they determined to look into all the findings from all the review boards that look into how the Polar Lander has failed and make sure that we address every single item that those review boards has raised. But in addition to that, the project also had time to do additional analysis as well as modeling and testing. And in fact, we uncovered a number of other items that really were not identified by those review boards.
Well, one of the things that is being done differently is the fact that there are a lot of eyes watching Phoenix go to Mars this time. Can you talk about the orbiters?
Sure, I certainly can. EDL is being so difficult. So we want to learn very much about each time when we have a chance, we want to learn what happened during the EDL process. So we have asked Phoenix to relay its engineering status information back to Earth. And on these graphics, you can see that both the Mars Reconnaissance Orbiter and the Odyssey spacecraft are flying overhead as Phoenix is going through its EDL process. And the data broadcasted by Phoenix is then captured and relayed back to Earth by these two orbiters. I want to also mention that we are very thankful to our European colleagues because they put their Mars Express spacecraft also overhead, allowing them also to capture this data. So we're kind of free-flow redundancy of how we can capture the data.
So it's factoring the idea that perhaps it may not be successful. If it's not, we're going to learn from this?
Absolutely. And the data that we can capture, no matter what happened, will allow us to learn and teach us what to do differently in the future.
And one last item, not only do we have the orbiters, but we also are listening to Phoenix from Earth. We have Green Bank.
Very much so. Again, we're grateful to the National Radio Observatory in Green Bank, West Virginia. They're going to turn their big antennas and they're going to listen to the UHF signal that Phoenix will be broadcasting. As it's broadcasting up towards the orbiters, they basically play the data all the way back to Earth. And the Green Bank will be listening, and we'll be listening for the same signal with them.
All right, Phuc Lee, thanks for joining us. You can go back into Mission Control and be there for those key moments. Thanks for joining us. Let's go back to Mission Control.